Welcome to the lesson. We are going to talk about three concepts: circumference of a circle, the length of an arc, and the area of a circle. And so, because I know we shall be using formulas, like we have the formula for the circumference of a circle, the area of a circle, and even the length of an arc. And all of them we are going to use pi. So we need to know the value of pi and even what is this pi. So to start, we have that for any circle, the circumference is always just over 3 times bigger than the radius. So the exact number is called pi. That is the name. And the symbol is the one shown here, because the number cannot be written exactly. So if we write it in figures, then it will be 3.14 going onwards. And you see, this is to 200 decimal places. Now, let's look at the approximation for the value of pi. So when we are doing calculations involving the value pi, we have to use an approximation for the value. And so, for a rough approximation, we can use 3 digits, and that is 3.14, or that should be 3.142, sorry, it should be 3.142, or 22/7. You can also use the pi button on a calculator. There's also a symbol for pi in the calculator. You can check. So most of the questions will tell you what approximations to use. In fact, in many questions, there will be a condition on the pi to use. The pi can be given as 3.142, or it can be given as 22/7. So it will be communicated in the question. Now let's shift our attention to the circumference of a circle, and we know that for any circle, pi will be circumference over diameter. So we have pi is equal to circumference over diameter, and we rearranging that, we have that circumference is equal to pi d, whereby the d there is for the diameter. So on this question, use pi is equal to 3.142, it should be 3.142, to find the circumference of this circle. So we substitute into the formula, so it will be 29.83 centimeters. The diameter of a circle is 2 times its radius. So we can also find the circumference of a circle given the radius. And in this case, we have that circumference is equal to 2 pi r, where 2r is for the diameter. So a question to show this, use pi is equal to 3.142 to find the circumference of the following circles. So there are a number of circles here. We have the diameter in the first case is 4 centimeter, and the circumference is 12.56 centimeter. So in this second one, it's a circle of radius 9 meters, and the circumference will be 56.52 meters. The third one is of a circle of diameter 23 millimeters. Circumference is 72.22 millimeters. And lastly, we are just using the formula and substituting, so it is just very easy. A circle of radius 58 centimeters, substitute, you get circumference 364.24 centimeters. Now, finding the radius given the circumference. Now it is vice versa. You have the circumference, now you want to find the radius. So use pi is equal to 3.142. It is good you use 3.142 because that is the standard number of decimal places to find the radius of this circle. So As you can see, circumference is 12. So we rearrange this to make R the subject of the formula. So of course we'll have R will be circumference over 2 pi, and then that will give you 1.91 centimeters to 2 decimal places. Yep. Find the length of an arc. Now, what is the length of an arc? That the arc is AB. Arc is AB from this circle of radius 6 centimeters. So the arc AB subtends an angle of 90 degrees, because this symbol is for 90 degrees at the center of this circle. And so we have that an arc is a section of the circumference. The length of an arc AB is a fraction of the length of the circumference. And to work out what fraction of the circumference it is, we look at the angle at the center. As you can see, it is 90 degrees because of the symbol. And so in this example, we have 90 degrees at the center of the circle. So what is the length of arc AB? I think now we can answer the question. So the arc length will be 90 over 360 degrees. That is the same as a quarter of the circumference of the circle. So we are going to take 1 over 4 times 2 pi r, because it is the formula for the length of an arc should be theta over 360 pi d or 2 pi r. So in this, it will be 1 over 4 times 2 times pi times 6, and that is 9.42 centimeters to 2 decimal place. Okay, for another one, for any circle with radius r and the angle at the center theta, then the arc length will be theta over 360 of the circumference, that is pi d or 2 pi r. So it is the circumference of the circle, and this can be the arc length AB can be given as 2 pi r theta over 360. That can be simplified to pi r theta over 180. You can just use the formula that you are familiar with, or rather is familiar to you. If this is just simplification, so I hope it's not going to confuse you. Now, let's look at this diagram. We are supposed to find the length of the arc AB. The length of the arc AB. The radius is not known. And now, this just, if you are told, assuming the radius was given, then probably you can find for the length, the arc length AB. Because you are going to use the formula, you substitute and get the answer there. Now, the perimeter of shapes made from arcs. Find the perimeter of these shapes on a centimeter square grid. So we shall start with the first one. The perimeter of this shape is made from 3 semicircles. So perimeter will be half times pi times 6 plus half times pi times 4 and half times pi times 2. So this will give you 6 pi, and that is 18.85 centimeters to 2 decimal places. On the other side, we take the angle at the center is 40. So if you are to get the perimeter of the shape, then we will take 40 over 360, that is 1 over 9. And so the perimeter will be 1 over 9 times pi times 12. And then 1 over 9 times pi times 6. And that will be 3 plus 3. You get now 2 pi plus 6. So the answer you get there is 12.28 centimeters to 2 decimal place. Now let's move to the area of circles and sectors. And starting very first, we can find the area of a circle using the formula. The formula is pi r squared. I think that is something we are familiar with. And now we want to use this formula to find the area of a circle of radius 7 centimeters. So using the formula pi r squared, it will be 3.142. If you use 3.142, you get a different answer. So, and because I'm using 3.14, my answer is 153.86 square centimeters. Another part, the radius of a circle is half of its diameter. Now we are finding the area of a circle given the diameter. And so that nothing will change in this. You will only use now the diameter. From the diameter you get the radius, from the diameter you get the radius, and you get it into the formula, and we can use it to answer this question here. Use pi 3.14 to find the area of the circle. So area of the radius of the circle is given as 2 centimeters. So we have area to be pi r squared. So if you calculate that, you get 12.56 square centimeters. What over a circle of diameter 10 meters? Using the formula, you'll get 78.5 meters square. And finally, on the third one, the radius 23 millimeters, you'll get 1661, that is 1661.06 square millimeters. The last one, we have a circle of diameter 78 centimeters. So using the formula, you get 4775.94 square centimeters. And now we want to look at how to find on the area of a sector. And a sector is also a part of a circle. And so with the formula, of course, we know that the area of a sector, it is going to be theta over 360 pi r squared, because it is the fraction of the area of the circle. So in this case, because the radius is 6 and the angle at the center is 72 degrees, so it will be 72 over 360 times pi times 6 squared. That will get us 18.85 square centimeters to 2 decimal places. Now we can use this method to find the area of any sector. And as we know, for any circle with radius r and the angle at the center, this will be the formula for the area of a sector A or B. It will be theta over 360 pi r squared, where pi r squared is the area of the circle. So we can now use the formula to find the area of the shapes made from the sectors. So find the area of these shapes on a centimeter square grid. So if you can find the area of the first one, it will be pi r squared. So this is a half times pi times 3 squared, plus a half times pi times 1 squared, minus 1/2 times pi times 2 squared, and so you get 3 pi squared. That is 9.42 square centimeters. Of course, it is a square grid, so the number of boxes, you count them. We have 1, 2, 3, 4, 5, 6. So that is where we are getting 3, 1, and 2. On the other part, we have 40 degrees at the center of this shape. So that means that it is 40 over 360. That is theta over 360. So that will give us 1 over 9 times pi times 6 squared. And then minus 1 over 9 times pi times 4 squared. So we'll get 1 over 9 times 20 times pi, and that is 6.98 square centimeters.